The next part of section 4.5 is finding domains and ranges of graphs. So as you see on this page of notes, we have multiple different kinds of graphs: circles and ovals, angled lines, horizontal and vertical lines, and some upwards, downwards facing parabolas, absolute value. So pretty much everything you might run into. Now when finding the domain and range of graphs, it's a little bit harder than when you're just giving sets of ordered pairs, because there the coordinates, x and y values, are right in front of you. So you're just listing a set of numbers. With a graph, you have kind of an infinite amount of x values and y values. So rather than just listing all those x and y values, that'd be impossible, because you can't list all the possible x values or y values. Rather, you have to give an interval of x and y values. So that's what we're going to do for all of these graphs. And one good way to think about domain and range, if domain is all the possible x values that you have, your x values kind of go from left to right, you're really thinking, how wide is my graph? Whereas your range, you're looking at all the possible y values. You know, how far up and down does this graph move? So with range, you're really thinking, how tall? How tall is my graph? And so the first example we have here is an oval. And ovals and circles both work the same way when you're trying to find your domain and range. So we can start by trying to find our domain and then our range. So domain, we're looking at how wide is this graph? Okay, how far to the left does it go, and how far to the right does it go? So looking at our graph, this is the furthest left point, right over here, at an x value of -7. And how far to the right does that move? All the way over here. This is the furthest right point on this oval, right here at an x value of +3. So the domain, what are the possible x values that this oval hits through? Well, it really hits through every x value ranging from -7 to +3. So when we are writing our domain, we want to write an interval that describes that. So our domain, writing in interval notation, it goes from -7 to +3. Those are all the x values that graph hits through. We do want to include -7 because it does touch -7. We do want to include 3 because the graph does touch 3 as far as an x value. So since we want them included, remember that's when we use a bracket. If we did not want to include those points, just everything in between them, that's when we would have used a parenthesis. So our domain is the point, or is the interval from -7 to 3. Our range is going to be looking at how tall is this graph? What is the lowest y value this graph hits through? What is the highest y value it hits through? So now we're looking kind of along the y-axis. The lowest point on the y-axis it looks like it hits is down here at -4. And then it kind of moves all the way up here, and the highest value any point hits looks like maybe up here at +2. So that right there, from -4 to +2, that's our range of y values. So we need an interval to describe that. It does indeed touch -4 and 2, so again we're going to have brackets around the -4 and around the 2. So that's how writing domain and range will always work for a circle or an oval, like we were just given here. Doesn't work like that for everything though. Next example, looking at, well, when you have two lines, or certain kinds of lines, when you have them that are angled like this. Okay, lines that are not horizontal or vertical. They're always going to have the same kind of domain and range. So thinking of this, the kind of idea of how wide and how tall. if you look at either of these two lines, okay, let's say this upward rising one for starters, how wide is it? Well, these arrows on the end indicate that this line moves forever to the left and forever to the right. As it's going up, it's moving to the right forever. As it's going kind of down over on this side, it's moving to the left forever. There is no restriction on how wide this line would be. It's going forever, left and right. So for a domain, it's going to hit through every possible x value eventually. If we made this graph bigger, it'd be going through, instead of just to -10, it'd be going to -20 and -30 and all the way to -infinity, all the way to positive infinity. So for our domain, it's really going from -infinity to positive infinity as far as our x values. And remember, infinities always get parentheses. But our range, how tall these graphs are, well, same idea. This graph is going down forever. It's going to hit through all possible negative y values, okay, on the y-axis. It's moving upwards forever. It's going to hit through all possible positive y values. And same with this graph here, going up forever, going down forever, going left forever, going right forever. So with any angled line, your range and your domain are always going to be all real numbers, or -infinity to infinity when we write it in interval notation. So this will always be the case when you have angled lines like this. So those will be hopefully an easy one to remember, or at least writing the domain and range. So look at our next two examples. We have an upward opening parabola here, but it works the same as if you had a downward opening parabola, and also the absolute value graph, which is a V shape. So kind of the same idea as a parabola, only instead of a curve, it's, you know, a sharp line and a sharp line. But they're going to have the same kind of idea when you're looking at domain and range. So let's talk about domain here. Okay, how wide is this parabola? Is there a limit to how far left and how far right this upward opening parabola goes? Well, as a parabola opens upward, it spreads out wider and wider. Okay, obviously the graph is wider up here at the arrows than it is down here close to the curve, close to the tip. And as this graph gets taller and taller, it's going to continue getting wider and wider, and it's eventually going to hit through every possible negative x value and every possible positive x value. It's never going to be limited to how wide it gets. So the domain of a parabola that opens upwards or downwards will always be the same. The domain will always be -infinity to infinity. There is no restriction on how wide that graph is going to get. It will continue spreading out as it opens upward or if it opened downward. So that's always going to be the case for the domain. Now the range is a little bit different story, because there is a limit to how tall a parabola is. Okay, how high it goes or how low it goes, depending if it opens upward or downward. In this parabola, it opens upward forever. There is no limit to how high it goes. However, there is a limit to how far low it goes. This minimum point we call this a vertex, but this is the ordered pair -4, -5. -4, comma, -5. Okay. So the y-coordinate of that point, that lowest point on the graph, is that -5 right there. -5 is the lowest y value that this parabola hits through. It hits every possible y value above -5, but that's the lowest. It's not going to ever go down to -6 or -8 or -10. You can see it's definitely -5 is the lowest y value it ever hits through. So when we write our range, well, the lowest it's ever going to hit is -5. Is there a limit to how high this graph is going to go? No. So the y values are going to go up forever. Positive infinity. Infinities always get parentheses. The graph actually does touch at -5. So that's going to get a bracket. So the domain of any parabola opening upward or downward will always be -infinity to infinity. The range is going to depend upon whatever your minimum value, your low end is, or whatever your high end is, if it's a downward opening parabola. So you just really have to be, think a little more when you're writing the range. And then lastly, horizontal or vertical lines. Okay. So with the horizontal line, let's start with that. This line right here, it crosses through the y-axis at the value 6. If you recall, that means the equation of this line is y equals 6. Because it only crosses the y-axis, it's a horizontal line, it's going to have the equation y equals some number, that number being 6. Whereas our vertical line only crosses through the x-axis, so it's going to have an equation of the form x equals some number, and it crosses through right here, the point 4. All the points along that vertical line are going to have an x coordinate of 4, meaning our equation is x equals 4 for that line. Alright, so let's talk about our horizontal line and our vertical lines, domain and range. So starting with the horizontal line, the y equals 6. Okay. So starting with domain, what possible x values does this graph hit through? Is there a limit to how wide this graph is? Going back to the top of the page. Domain is how wide is this graph? Well, this graph goes left forever, this graph is going to go right forever. It's going to hit through all the way through all of the x values, the negative x values, all through the possible positive x values. There is no limit. So the domain, it's going to hit through all possible x values from negative infinity to infinity. This will always be the case with a horizontal line. Think of any horizontal line. It's going to continue forever to the left and to the right. Now the range, what are all the possible y values this graph is going to hit through? There's only one y coordinate for any point on this line. Every y coordinate is going to be 6. Okay, this is the point 0.6 here at the y-intercept. Over here this would be the point 0.86. Over here this would be the point -4.6. The only possible y value is 6. So the range is just the set of the number 6. And that's how you would write that. For a vertical line, kind of think about it similarly. It's just going to be reversed. Which one is always the same and which one is going to change each time. For a vertical line, think of our domain. Okay. Our domain of our vertical line x equals 4. Domain are all the possible x values this graph will ever hit through. Well, anywhere on this vertical line, the x values are always going to be 4. This is the point 40. This would be the point 46. The point 4 -8 would be down here. The only possible x value you're going to ever touch on that line is the x value 4. So our domain is just the set of the number 4. Whereas our range, well, any vertical line is going to go up forever and going to go down forever. There's no limit to how tall a vertical line will get or how low it will get. So the range will always be negative infinity to infinity for any vertical line. So that will always be the case for a vertical line. So a horizontal line will always have a domain from negative infinity to infinity. A vertical line will always have a range of negative infinity to infinity. We'll continue with 4.5 in the next video.